this presentation, it's going to be all about improving efficiency in scan to BIM projects. I think it's no longer doubted that the most efficient way of capturing as-built information is through laser scanning. And the technology has proved itself in many industries and for many applications. It's now the only method of efficient data capture. But that doesn't stop us wanting to be faster and still even more efficient and more profitable, obviously. As the technology has grown, the markets become more competitive, and therein it becomes more important for us to become more efficient in what we do when it comes to scan to BIM. So today I'm going to try and break down that agenda, that topic of becoming efficient into the processes that we go through when we do this, embark on the scan to BIM. Break it down into sort of what we can do with our data capture, what we can do with data processing, data management, and then obviously the data extraction, actually taking the data out into the BIM model. And then also look at the possibilities that we have with sort of in-field data analysis as well. There'll be some tips and tricks and some advice on what I found to work well for myself over the years. Yeah, so let's get started with the introduction, and I'll start by introducing myself. I'm Brent Godfrey, and I'm the Construction Technology Manager here at Building Point South Africa. I've had quite a varied career that spanned over both the construction and survey industries over the last 22 years. And it's taken me to many interesting places, from working in tunnels across London to mines in Tabazimbi, and almost all forms of construction sites in between. I think my passion for construction technology comes from seeing how differently we work in different parts of the world, and the importance of needing to work smarter rather than work harder. So maybe it's because I'm lazy, but lazy in a good way, I suppose. So if we look at the Optron Group, we start at the top. So the Optron Group was established in 1986. The group's been a Trimble regional partner supplying advanced positioning technologies throughout Africa for 37 years. The Optron Group is structured with subsidiary companies segmented so that they can focus on the industries that they serve. Probably best known for the Optron Pty Limited. They have served the geospatial and survey sector for many years. Then we also have a heavy civils division called Sartec, and that heavy civils division, these are the guys that fit precision and automated guidance systems onto large earth moving equipment and sell and support bespoke civil engineering survey applications and equipment. We also have Vantage. They supply to the agricultural sector. They enable more efficient soil preparation, planting, pest control, and harvesting. They add all sorts of Trimble's positioning technologies to this industry. And then there's the Building Point division. This is where I reside. And we support and provide solutions to everybody operating in the AEC, so architecture, engineering, and construction space. With tools such as, you may be familiar with tools such as SketchUp and mixed reality and augmented reality, Tekla structural design software for engineers, and layout tools and 3D scanners for contractors. And then also the communication and collaboration platforms that help all these disciplines seamlessly work together as well. Just if we look at what we're wanting to achieve with this On Point webinar series, we're the third one in. We have all these office solutions like the Tekla structures, the SketchUp, construction verification stuff with Field Link, and point cloud processing with RealWorks. Then we also have all these field solutions. We have layout tools, advanced layout tools, robotic total stations, GNSS receivers. We also have a series of laser scanners, and augmented and mixed reality applications and hardware and apps for your mobile devices. And what we're wanting to do is we're wanting to show how they integrate with your existing infrastructure and how they interface with each other. And how when they're used together, they can create these optimized workflows. And through these better workflows, how this is going to help us better collaborate and communicate and improve our bottom line. So that's essentially what this on-point series is about. So if we get into why we're actually here, we're wanting to hear about this efficiency, scanning efficiency, and we're going to start with the data capture side of it. One of the first things that a lot of people, the first thing that springs to your mind when it comes to being efficient with data capturing is your scanner speed. A lot of people come and say, well, you know, the faster I scan, the more data I'm going to capture, the quicker I'm going to get to my end deliverable. So let's choose a piece of hardware that's going to scan fast. So let's look at this. We look at the Trimble range of scanners. We've got everything from our trusty workhorse on the left-hand side, our X7, to our TX8. Now we're starting to move faster, longer range, and right up to our top-end solution, which is our X12. Now, this X12 scanner, it really is an impressive piece of engineering. I don't usually like to rattle off specifications, but I think this scanner's earned its airtime for this. The scanner is capable of scanning at 2.2 million points per second. It can scan to a range of 365 meters. It's got sub-millimeter accuracy to beyond 100 meters. I think we get to about 1.5 millimeters at 200 meters, point spacings of 5 millimeters at 100 meters away, full HDR imagery. Really is, it's a fantastic piece of equipment. So after saying all that, you might be surprised to say, if I wanted to choose the most efficient piece of scanning for my day-to-day work, I'm actually going to go with the little guy on the left-hand side. And let me explain, let me try and tell you why. So yes, with scan speed also comes an increase in density, and there are effects on efficiency. So when we scan faster, we may reduce our time in the field, a few seconds or so, half a minute per scan, and we will capture higher density data. That's correct, that's true. But with that, we're going to also decrease our efficiency by mainly increasing the file sizes that we capture. With an increased file size, that's going to increase certain aspects, which is our processing time with that data. Now we're going to process our scan data at many stages through our project. It'll happen when we register our data. We're going to process it again when we colorize our data, when we transfer our data from our devices from the scanner to your computer, from your computer to your backup, from your backup to the cloud. And then also when you share your data with other people, that's going to decrease our efficiency. It's also going to increase our storage requirements, our archive costs, time for retrieval of archiving. And also we need to understand that the software we're going to be modeling in, we understand we should be scanning to within the capabilities of our modeling software. Our modeling software is fantastic. It's design software, and it does our design, and it does design very well. And a lot of them have got capabilities of bringing in point clouds, but they're not necessarily point cloud processing software. So if you're in the business of capturing scan data and processing scan data, and you deliver it to somebody else, they might not be experiencing the same performance that you do with that point cloud that you're generating. So I like to try and keep my file sizes to, we look at sort of where that sweet spot is. I try to keep my file sizes to around 80 megabytes per scan. That's sitting at the lower end of the spectrum. It's considered sort of a low density scan. But note at this range, your scanning spectrum, your time versus density versus file size, not that much different between your fast and your slow scanners. You've got 1 second in time, 2 millimeters in point spacing, and about 5 megabytes in your file size. So, there's not a huge efficiency in the field with choosing that scanner to the left-hand side of the spectrum. But how can you keep your file sizes small, but still capture the detail where it's required? So yes, you're scanning at a lower density, but you still do need detail. I'm not saying you don't need detail. And there's certain situations where you do need high density scan data. One of them being control targets. So being able to get enough density on your checkerboard targets to be able to, when you want to create families, for example, so a facade of a building may have 200 windows. So 199 of those windows, all you really need to know about them is the position of where they are. For one of them, you need to know enough detail on how to create that window family object or that object of that window. And then the other scenarios are for industrial applications. So usually in brownfield projects, you need to know the detail on where the interface between where the old meets the new. Those are kind of the areas and examples of where you need high density data. What we can do is we can scan let's take a look at the example of the control targets. So we can scan at a low density, and we can just add high density sections of a scan in different places. So we don't have to do a full high density scan every single time. So yeah, in the case of the black and white target, the higher the density of the points you get on your target, the better your software is going to be able to resolve the position of the targets. That's why we need to do it. So for those new to scanning on this webinar, we use these targets for known positions to position our scans on site to the site coordinate system. And in some cases, we also use them to align scans. But we want high density but small files. So we're able to do this low density scan and just add these small areas of interest that we need to be added at a high density. So you will see here in the top window, that's the full scan this was just downstairs in the basement of our office, where I put these targets up at different distances away. It's sort of 10 meters, 25 meters, and 50 meters. And at the top, you'll see that's my sort of low density scan. And then I just did a small window below it at a higher density, and you can see the difference in the resolution where you're able to identify targets at those different distances. And the workflow is really simple. I mean, on board the scanner, once you've done your low density scan, you can just add as many different areas that you want. You can just add a little rectangular block or a vertical or a horizontal window, choose the density that you want of just that small isolated area. You can also choose whether you want it to be in color, whether you want it to be in HDR color. And you can add as many of these windows into a scan as you need. Once you've got however many you want, 2, 3, 4, 5, just hit the play button and it'll just go through all those windows that you've added. But yeah, what we've been able to achieve is we've been able to achieve a small size, and we've been able to achieve what we wanted to, which is accuracy on our scan targets. So when I compare that, what we were able to extract the positions of our scan targets from that data set compared to, say, they're measured with a total station, we're still getting around that 2 millimeter mark at 50 meters away. But our file sizes are, again, they're quite small. So that option of being able to just scan isolated areas according to what you require is a really good thing to try and do. The other thing, sometimes people send me files and their projects and they want help with them. I get these very large files, and you ask, why has it been scanned to that density? And the answer is, well, they say the density helps you identify detail. So it needed to be a detailed scan. So let's look at this picture. This is just a single room. Let's look at the corner, for example, just the cornicing of this room. We're wanting to just model and identify the detail in that of the cornicing. Here we have a very high density scan, and you can see there's lots of points, there's lots of data there. But if you look at it low density, you can actually identify more detail in a smaller, lighter scan than there is in a heavy, dense scan. We're seeing things in 2D, so sometimes the projection of you can where points overlap with each other, you can identify changes in height, changes in direction. The scan lines almost act as contours on flat surfaces when you can actually see the scan lines in your data set. So detail is achieved with having these smaller scans. But if you're wanting to add detail to your scans, it doesn't have to be done with point cloud data. You can also add annotations to your scan data in the field by using the tablet. So the X7 scanner, you operate it from a field tablet, and you can take images and tag these images and add notes and all the annotations in within your scan without having to actually go up to them and scan them in a lot of detail. It can be useful for doing things like tagging serial numbers of assets in your data set, getting room IDs, noting the positions and invert depths of manholes, and those type of things without having to actually go up and scan inside the manhole, or make sure you've got room IDs in your scan data set. So that was the data capture. And the takeaway from there should be just keep it light. It really helps. When I talk about data processing now, I refer to the georeferencing, the registration, and the refinement of your scans. So with the X7, it's got a built-in laser pointer in the scanner. We're able to use this laser pointer to aim at control points, so known features or points from a model that have been loaded onto the scanner. And we can measure these points to align our scan to the grid or the system we want it to be in. So surveyors would call this a resection. We do this resection with our scanner to georeference it on site. We also have register and refine options on the scanner. So registration is the aligning of multiple point scans of the same object or the same scene into the single coordinate system. So they all sit relative to each other. And this is done by finding corresponding points in different scans and calculating their transformations. The scanner's got a built-in IMU system in it. So when you pick it up and move it, it's got a pretty good idea for a starting point as where to start this registration calculation. So it's able to be done very quickly and out in the field as you're scanning. So it does this point-to-point cloud matching. So as you move along throughout your data capturing throughout your site. And then once we complete, we can run a final refinement of the scan. So we've got by the end of the day, we've got a fully stitched together, refined, ready to go, positioned to site grid scan system before we've even got back to the office. And it can be very useful having this onboard scanning registration, especially in busy environments like construction sites or plant, where you're able to see and confirm that you've captured all the data before you head back to the office. So there's no revisiting site because something was missed. You can be confident that once it's done, it's complete. It's finished, it's registered, refined, ready to go, ready to issue. So on that topic of issuing your data, sending your data, it's important to know that these scanners, they capture a lot of information. They scan up to 300 meters away from you. So with that, you've got quite a big data set. So on the left-hand side, right-hand side of the picture you're seeing now, this is two different software packages opening up the same point cloud. On the right-hand side is your Trimble RealWorks, your point cloud processing software. And you can see how that seamlessly opens and manages billions of points and without sweating. And it is a dedicated point cloud processing tool. You may be delivering that it may be shared with your client or other people in the project team, and they will be opening it in their modeling software or other software tools that have point cloud capabilities, viewing capabilities. And don't be surprised when people, when guys come back to you and they say, look, the data set's useless to me. I can't use it. I can't open it. You can see the difference between that, the data set on the left-hand side is still busy trying to load voxel, area by area. So what we're wanting to do when we deliver that data, we want to crop out all the unnecessary information. Just focus on what's required. Just issue that section of data to your client that they've asked for. That can also be done directly out in the field with your scanner. We've got the ability to use a clipping box where we can clip out just the area of interest. So now we have a fully geo-referenced, fully refined data set clipped out just with the area of interest that we want to deliver to our client. And then we can export it and we can deliver it in whatever software they've asked for, any software that they're going to use it. So whether they are an Autodesk user, we can export an RCP file. So for those Revit users, the Autodesk plant, Civil 3D, we can export an RCP file. We can export pod files for our Bentley users. There's TZF files for SketchUp users, E57s for guys that are using ArchiCAD. So now, again, without having to go back to the office and do any processing, we have now our geo-referenced, refined, clipped, and correct file format already packaged and exported without the need for going back to the office. So that's a really good efficiency to look for, is being able to do that type of thing with your survey equipment. So now let's get on to data management. So we have these large scan files, and a lot of the time it's time consuming. And keeping a copy of it, making sure it's backed up, transferring it from being able to find a USB drive with 100 gigs free on it and being able to transfer data with external hard drives. Maybe you've got NAS drives set up to create backup copies. Then when you're having to try and create duplicate offsite copies as well, you might edit your on-site version, and then you're trying to keep things up to date to make sure that any changes that are made are reflected anywhere in your within your backup data set. Can be quite tricky. And there's, it is quite a challenge when you do lots of scanning to sort of manage that scanned data. And also the storage of that data can be expensive. So if we look at on the left-hand side, we're looking at this tablet, the view that we've got on our tablet. On the right-hand side, we're looking at one of Trimble's common data environment, the Trimble Connect. And you can see that's where all the project teams, architects, engineers, they collaborate and share all their models and all their design information. You can store your data up there on the cloud, issue people drawings, requests for setting out that type of thing, can all be done through Trimble Connect. And as you can see in my scanner, I've got an option for all my projects. I can see all those online projects as well. So I can store my information to Trimble Connect. I can retrieve models and retrieve information from Trimble Connect as well. So I've got this access directly to my common data environment from my scanner. We can even set up syncing between your scanner and your common data environment. You can back up all your project data, and when you set it up, you can even have it so your scanner syncs up to the cloud, syncs up to Trimble Connect, say every 15 minutes. So that would be about every possibly 3 scans. The data is automatically syncing up to the cloud. You can then set up your Connect Sync Manager to download that data from the cloud down to your local PC sitting in your office, so that by the time you get back to the office, not only do you have your data stored and backed up on the scanner itself, but you've also got a cloud storage backup, and you've also got a local your data is sitting there on your computer ready for you to do whatever, make whatever changes or work on it straight away. And then whatever edits and stuff you make to your data, you can set up whatever syncing intervals, possibly daily, you wanted to update in a different folder, that your working folder, your edited folder gets synced up to the cloud once a day, and anybody can have access to it and see where see the changes you have, and then it just manages that challenge of making sure that your on-site and your off-site copies are mirroring, are the same. Okay, so let's look at data extraction. As we said, your modeling software is not necessarily dedicated point cloud software. So the aim is to scan within the capabilities of your modeling software. Limit the area you export to limit boxes, manage the density of your point cloud data. Also consider using automated extraction of intelligent BIM objects. Use third-party software to assist with your modeling process. I find things like walls, doors, windows, ceilings, those type of things. Those are the kind of things you just got to sit down and get through them. It's not really, I don't think there's much of a faster way of doing it than actually just getting it done, loaded and just. But the things that are going to areas where I think are more challenging are steel beam extracting of one of the areas is steel structures. Being able to fit every single steel frame to the correct frame, the steel member size in your catalog, that can be a time-consuming process. So those kind of things are quite nice to use third-party software to improve that, speed up that workflow. In this little video playing here, this is Trimble RealWorks, and Trimble RealWorks has got a workflow where you can. So here's a scan of it inside and outside of just a portal frame shed, and it'll automatically identify what are the steel frame, what is the steel frame point cloud, the points on the steel frame and the structure. And I've now cleaned up and cleared out my entire data set, and all I'm left is with my steel frame structure. And it took as long as what it took in that video to play to process that data set, and I now have my steel members that I can extract. Now, for the actual extraction part of it, my preferred go-to tool is Edgewire software. It does a really good job at identifying member sizes according to a catalog. So you can very quickly and efficiently extract your steel members. You can also extract a pattern of steel members. So I can identify a pattern. Say, for example, it's all your steel members in one of your sections of your portal frame, and I can say go find that truss and give it a direction. So down that direction, look for that truss, that typical trust member, and we'll go through your point cloud and we'll add all that. We'll find all those groups or common groups of steel members throughout your data set. So it's a very efficient way of extracting steel frame structures out of your point cloud. And the other nice thing is it plugs into software like Plant 3D and Revit, and you can export Revit family objects, and so you get your intelligent objects inside your modeling software. Another way we can help place where that takes time in your scan to BIM is piping. So being able to extract pipes from point clouds is also time-consuming process. In this little video here, I like to use Trimble RealWorks for this. It's really easy to use, really quick. You can extract your model again according to standards. It's got direct Revit integration. You can even model in the sag of pipes, pipe sag, into your extraction. You can extract your flanges and your valves and your bends and your reducers and everything that makes up your pipe runs and your pipe networks. And then when you, as I say, it does have Revit integration as well. So when you bring it in, you can choose what system it's going those pipe runs apply to. You can see what the pipe types, the bend types, the different. You can choose the family category as well of the pipes as they as you import them. So it's got some really good Revit integration as well. RealWorks for the on its piping module. So now let's look at in-field data analysis. Now, we've said that we've shown that we can, on the data collection side, we can have a completed scan data set, georeferenced, registered, refined, according to our, on our site grid out in the field. Now, we can also bring our BIM model out onto our scanner. Instead of taking the scan data back to the office to do analysis back there, and then have your turnaround and your answers sent back to site possibly the next day. We can take our BIM model out to site onto our scanner, and we can do those deviation analysis and comparisons out in the field and give immediate results. So that definitely adds more value to your scanner investment. There's so many more applications that you can use it for, as opposed to just the data collection. It can be used for in a very efficient workflow for QA, QC. Some of the applications we come across that we find sort of have been useful. Usually things that are on the critical path of a construction project are things like checking to see the alignment of your facade before that goes in, checking to see if your slab edges are aligned before the facade goes up. These are things you don't want to have surprise you later on as your project goes on. Another application is lift shaft verticality. Being able to, it's an example, I think, of a 15-story lift shaft done in about 3 hours on site, scanned, registered, refined, inspection done, and highlighted any deviations. Checking your horizontal and vertical cover for your rebar, checking the formwork, the position and plumbness of your formwork, doing things like inspecting the flatness of floors. So especially we've got warehousing and stuff, we have these high tolerance, we now have these high racking systems. So we need to have high tolerance on our floor levels with all these TR34 specifications. And we have what we're able to do is we can scan the floor while the concrete is still wet. We can identify where it's high and where it's low. And because that scanner has the laser pointer built into it, we can just tap on our screen where it's high and low, and the scanner will point out on site, and it'll point to the high spot, and it'll point to the low spot, and the teams on site can rectify that before the concrete sets. So before it becomes more expensive. Another cool application of being able to do this on site, this thing is assembly inspection. So an assembly is usually a component that's made up in a steel fabrication workshop or something like that, and it could be, I'll use the example of say a pressure vessel or something that's could be something that's difficult to fabricate, and you want to make sure that it's been fabricated right before it gets put onto a load bed, flatbed, and shipped out to site. I can take that model, and usually our model is in the orientation of how it's going to be installed on site. So probably sitting vertically up, but that's not necessarily how you're going to find it on site when you go to check it. When you go to check it, it's probably going to be lying on its side, or in an awkward position. So what we can do is we can actually select points on that object, and we can align with our laser pointer, align the scanner's axes to that object. The scanner automatically aligns its axes to that object, and then you can scan and do that comparison inside. So on site. So in this example, you'll see this object, it's sitting on a pallet, which is sitting flat on the floor, but the pallet's not flat on the floor because the axis of the scanner has actually aligned itself to that object, so that we're able to do a comparison between the design and the point cloud as it's however you find it sitting on the workshop floor. When we put this all and put it all into practice, sort of look at a quick workflow. Here we have a construction site. We've done our scans. We now set our tolerances. We do our analysis, do our inspection. Here we've got our 3D model, got our point cloud. We're now highlighting where there are deviations. There's very simple color coding to identify where these deviations are happening. We can also do things like, it's not only 3D models. Here we've got a PDF we put in our background as well. So sometimes there's a lot of information that's not in the model that you can identify in a PDF, such as the column number, a grid line position, or some other information, contextual information that's usually only on a PDF. We can have that. The scanner can actually orientate and scale a PDF onto your site plan as well. So now we've identified where these deviations are. We now need to create an as-built plan. So we export that data into the correct file format, which in this case has been done in Civil 3D. So we've exported a recap file. And I don't need to go now through the entire data set at this stage and start to look and try and identify where these deviations and stuff are and measure every single column, because I already know that. I only need to go straight to the column that I know there's a deviation for. It's color-coded in my point cloud, and I just need to annotate and mark just those single columns. So I'm reducing that whole time to do my analysis and being able to produce my traditional 2D PDF results of my as-built plan. I'm only documenting where things are out of tolerance. But now that's all done. That's all very well and good. But again, we're identifying things once they've already gone wrong. So it's nice, but I believe this is where the real value of being able to have this information out in the field is to identify these problems, these issues before they've gone wrong. So in this case, here we have a column. We've done a scan, and we can immediately see that sort of the rebar is sitting on the outside of that column. So we can now start to make those changes before it gets cast. We can see that this column is right next to, it's next to a fire escape. So the cost of the rework of that column, if it had gone up in that position, it's not necessarily just the cost of the concrete inside the column. It may have an architect may have needed to be involved because the handrail wouldn't fit past the column, or the fire engineer then needed to get involved because now the width of the staircase, it's a fire escape, is not wide enough, or the structural engineer needed to get involved because, as you can see, it's almost a column width out. So there's lots of other peoples and times and delays. I mean, that little portion of the building may have always been one level below, while all that detail gets ironed out. And it's, yeah, the knock-on effects of these type of things, those kind of costs, which don't necessarily always get accounted for or calculated. Those are the kind of things we can prevent by being able to have this high detail scan information out in the field, on site. So that, to me, that is really utilizing your scanner to create really efficient workflows, to make a company more efficient. So in summary, why did I choose that scanner right on the left? I didn't even mention these first two topics. It's a self-leveling scanner, self-calibrating, doesn't need to go away for an annual service to get a calibration certificate. It calibrates itself. The auto registering, the in-field georeferencing, that seamless field to office, office to field data management, data size versus time with those area scan capabilities, those in-field analysis, so for fast turnaround time on results, and being able to export your data to sort of your industry formats directly from on board your scanner. So I think that's my summary of my my tips and tricks for the for this presentation. So I would like to open it up to if anybody has any questions for me on what I've presented. Yeah, please fire away. So let me just. Okay, there's one question. What is the cost linked to range? What is the life cycle like? The costs linked to the range. So I'm assuming you're meaning the costs between sort of the scanners as you go up from sort of the short range through to the longer range. I mean, you have costs of your scanners on the lower end. You're going from around from under $1 million to 2 million on the other end of the scale. A lot of things with range as well is it really depends on the environment and what you're scanning. It's very rare that you're going to get a scenario where you're actually going to scan 300 meters unobstructed. There are situations, obviously, where you do need that, but you usually have to pick up your scanner and move it around to make sure you get full coverage anyway. So range for me is, I quite like that sort of 80 to 120 meters. To me, that's a good range for a scanner. Is that so if that answers your question.
Brent, we can open up the mics for everybody if they want to ask a question, or they can answer you openly.
Yeah, please do.
Yeah.
Is that something that I need to do?
No, not at all, but you can just, we can just announce that people can actually just unmute and ask questions if they want. But there is another one from Stephen on the chat if you'd like to look.
Okay, there we go. Another one from Stephen. Can I just expand on the self-calibration of the scanner? Yeah, so the scanner itself, it's actually got a little sensor inside. So it actually checks itself before every single scan. It does a horizontal and a vertical alignment check. It does a beam laser check. It does a I've got somebody at the door who's about to bring me one in, so I can show it to you. Don't know if you're going to be able to see inside there, but just inside over there, there's a little window where it actually calibrates its laser there as well. It does a little, calibrates its compensator. So I can, at any point in time, I can say, run a calibration test on itself and give me a report. So if I need to, for example, do a scan in a forensics environment, you can imagine you can't, you need to have, if it's going to be submitted for evidence, you need to make sure you're using calibrated equipment. I can, before every time I go and capture a scene, I can run a calibration, and I can have a calibrate, and I can it'll print out a PDF report, and I can have a full calibration report of that device. So it's not just something, that we say it's going to do. That's the manufacturer specification, that calibration report is the calibration report for the piece of equipment. It also comes with a 2-year warranty as well. So, your maintenance costs of the equipment is very low. Okay, Alan, I see you've got your hand up. Please,
How's Brent? With being familiar with these E57 files and using it in Tekla structures,
yes,
we're looking for a way to basically just show that on a drawing. We want to show the client, this is your point cloud, especially on the brownfields project, and this is your point cloud, this is the alterations that we need to do. But I fiddled around in Tekla, but just cannot get that point cloud to show on a drawing. Is there a way to do it? I've seen a workaround using Trimble RealWorks to bring in the E57 and export as a DXF, but that's a bit of a long workaround on that one.
I'll have to check with Mishant on that, on how Tekla handles that. Okay, so you want it on the drawing. So you can also share the point cloud data through Trimble Connect as well, because Trimble Connect desktop can view the point cloud data. But I'm assuming you don't want to share that information with them. It's just to show.
Well, but basically, if I can share my screen, I can show you what I want to show them.
Yeah, please go ahead.
Yeah, can you see the model?
Yeah.
So I just want to basically give them a section of this, because all the colorful things, all the new walkways that we're introducing to a glass plant, and it would just be nice to show them the surrounding steelwork around it, but it just cannot be done. Well, maybe I'm overlooking something.
Sure, I'm going to have to check with Mishant on how to do that in Tekla. I'm pretty sure it can be done.
Hello?
Yeah, hello.
Hi, Brent, can you hear me?
Yeah, can you?
Hi, Brent. Okay, so I don't know, I'm not sure who asked the question, but you can show your Tekla model with the point cloud in. It'll just come in as a reference object in your drawing. So you can bring it in as I'll have to get the right terminology for you, but you can bring it in to show it in your drawings, and it'll even come in as like a lighter shade. So when you print it, it'll come in as like more of a shadow over your actual work.
They say it's under the reference tabs.
Yeah, so if you go into your drawings,
Okay.
there'll be something they call neighboring part. So you can add it in as a neighboring part.
Neighboring, okay. No, I'll go check that out.
So maybe just go have a look at it. If you don't come right, you can obviously more than welcome to contact me and I'll walk you through the process.
Okay, no, that's kind of you. Thanks.
Okay, thank you.
Thanks for that. Thanks for that, Mishant. Appreciate that. Mishant's our Tekla building point tech support guru. So he see, you've still got your hand up, Alan. Do you have another question?
No, I just forgot to put my hand down.
Okay.
It's a bad habit.
Okay, guys, if there's no more questions, yeah, there will be a recording of the presentation. These are our social media handles. You can get on screen now. You can contact us or follow us on any of these social media platforms. It's also in the chat box at the moment. So all our Instagram and our YouTube and our LinkedIn, all the links to our social medias is now in the chat box to this meeting now. If you're wanting to view them.
Brent, can you just share your screen again? Because
stop sharing. Sorry.
Yeah, well, yeah, we just had Alan that took over. So there we go. Great, got it.
Is it back?
Yeah.
Fantastic.
There's also a question from Biff.
Yeah, go ahead, Biff. Is it in the chat box? Is it?
Yes, it is.
There we go. When scanning high precision floors very accurately, what distances typically do you take between scan positions? Thanks, Biff. It's quite close. So I'd probably do it at about 10, 15 meters apart when doing floors. What you do is you want to, obviously, you understand the concept of being familiar with scanning is when you scan onto surfaces that are, you don't want to have that sort of angle of incidence too high. Your point data becomes a lot sparser further away. I like to crop out the area within the first 2 meters of my scan data, and I crop out scan data beyond about 20 meters of my scan, and I do it scan intervals of about 10 meters, 10 to 15 meters. That I find gives you that, you're in that high precision range of your scanner. You don't have any data loss from accuracy loss because of any distances. And you get really good registration sort of results when doing it like that. And the other nice thing about the X7 scanner when doing these high precision floors is the fact that it has a built-in, well, its compensator it's a survey grade compensator. So its accuracy is 0.2 of a millimeter over 20 meters. So over the range of the scanner of 80 meters, you're sitting within 2 millimeters of your horizontal plane. So great tool for doing floor inspections. You can rely on the compensator of the scanner without having to, giving you your true horizontal plane, as opposed to having to go back and check against survey targets as well. So that's the other reason why we're able to do that in the field while scanning. So we don't have to check to see our horizontal plane is true and horizontal against survey targets. A scan that's done immediately we know is true and horizontal. So we can start to do those live in-field analysis of horizontal planes and floors and things like that. If does that answer your question, Viv? I see John. Yeah.
Hi, Brent. Hello, everybody. Yeah, just in reference to Biff's question there about floors, just wanted to. I know you didn't touch too much on the sort of precision scanning of floors within this particular webinar, but in case anyone hasn't seen it, if you visit the Building Point pages on LinkedIn, there's a really good post that you recently did about the scanning of a warehouse floor and sort of superimposing the scan on that floor via our sort of augmented mixed reality solutions, both apps and sort of headsets or on your mobile phone. It's an excellent post. It's one of our best followed and reshared posts that we've ever done. So yeah, if you haven't seen, if anyone listening to this webinar hasn't seen that, make sure you go and have a look at it, because it really paints the picture of what Brent's just been talking about there, Biff.
Yeah, thanks, John. Yeah, I think that application of floors is becoming is a topical one when it comes now to scanning as well. I think that, you know, warehousing is becoming one of is probably one of the strongest performing sectors in construction and in property development in South Africa at the moment. I think South Africa is becoming the sort of infrastructure hub, transport hub for Africa. So we have lots of warehousing and stuff that's busy going up at the moment. So yeah, it's a great industry to get into, sort of using scanning and verifying of floors and flatnesses and things like that. Okay, guys, I don't know if there's no more questions coming. If you do have any questions, please, yeah, do reach out to me. Reach out to us on any of these channels. And yeah, feel free to make contact. Happy to answer any questions afterwards as well. And yeah, thank you everybody for your time this afternoon. And hopefully everybody that's traveling for the long weekend, please travel safe, enjoy your weekend, and we'll hear from you soon.